30 years after its inception, the James Webb Space Telescope was launched from French Guiana on Christmas Day. 2 years ago, on December 28, it passed by the Moon. On January 24, it fired its engines for 5 minutes before entering its final orbit, which was 1.5 million kilometers away from Earth. After months of tedious setup, it finally generated its first image on July 12 of last year, showing us distant galaxies for the first time as they appeared more than 13 billion years ago. Previously, the earliest galaxies we could see just looked like little smudges, yet those smudges represent millions or even billions of stars at the beginning of the universe. Now we can see that some of them are actually extended objects with visible structures. Nearly all of the main space telescopes, including Hubble, the Chandra X-ray Observatory, and NASA's now-retired Spitzer, have conducted substantial research on the 2 locations used in this study, collectively referred to as Good South. 93% of the newly discovered galaxies that Webb found during this study had never been observed previously. Despite prior examination, only the brightest, most extreme instances of brilliant galaxies from the early cosmos were visible to us before. Now that the cosmos is still young and tumultuous, we are actually drilling down to more common, everyday galaxies. There's been much discussion on how exactly that chaotic, extremely dusty environment became the transparent universe we know today. One popular theory holds that this stage of the universe's evolution, known as the epoch of reionization, happened about 400,000 years after the Big Bang, when the first generation of stars, estimated to be 30 to 300 times as massive and millions of times brighter than our Sun, formed and illuminated the previously dark universe by dividing the cosmos's plentiful hydrogen atoms into protons and electrons. This ultraviolet radiation reionized the universe, a process that continued for 1 billion years after the Big Bang. Few researchers, however, believe that outflows from supermassive black holes, like the one in the center of our Milky Way, may have caused ultraviolet radiation from galaxies to escape and, as a result, may have had a more significant impact on cosmic development than previously assumed. Now a second team that has been researching galaxies between 500 and 850 million years after the Big Bang, or between 5 and 8 minutes of the 2-hour movie describing the universe, believes it has the solution to the age-old query. In this next scene of the universe, we are starting to actually see the impact of galaxy formation on the composition of the large-scale universe. Galaxies in the very early universe were just far more chaotic in general in how they formed stars. In order to understand how starlight ionized the gas within those extremely early galaxies, the team examined the signals of star formation in those galaxies, a property that atoms ionized by starlight radiate when they have cooled and merged with other molecules. The researchers discovered that 1 in 6 galaxies at the time displayed severe line emissions in the galaxy spectrum. These emission lines show that early galaxies were producing stars actively, which led to torrents of ultraviolet photons being blasted into each galaxy. As a result, the early stars of the cosmos turned into the primary forces for cosmic reionization. The team claims that in the very early universe, these strong emission lines are actually very typical. These remarkably strong emission line fingerprints, which indicate intense recent star. Since then, the Webb telescope has continued to build upon this incredible foundation. It appears that the threshold has been lifted once more, and Webb is ushering in a new era of astronomy and space exploration. Its most recent photographs serve as proof of both humanity's capacity for discovery and its complete insignificance. Join us as we explore the new image captured by the James Webb Telescope that reveals the secrets of the universe. In actuality, telescopes are not physically peering back in time when they observe the light from distant galaxies. No one is able to directly gaze at the past because it no longer exists. Instead, the telescopes are observing a beam of light's current pattern. The beam of light has been essentially undisturbed for millions of years as it moves through the mostly empty vacuum of space. As a result, the pattern of this light beam at the present time is the same as the pattern it had when it was first produced by the far-off galaxy millions of years ago. We can therefore infer about the galaxy's appearance millions of years ago by observing a beam of light in its current state. It's comparable to printing out a baby photo of your daughter and then looking at it 10 years later. You are metaphorically looking back in time when you look at the printed photo to see what your daughter looked like as a baby. However, you are not actually seeing back in time. Your daughter is not a baby anymore, and she doesn't have a baby self anywhere in the universe. Instead, you are viewing a current lighting pattern that was produced by the printed photograph's inks reflecting the light in the surrounding space. Imagine, for example, that some acid spills on the image and a large white dot appears above your daughter's head. When gazing at the image, you would have to assume that your girl was being watched by a UFO or a ball of lightning 10 years ago if you were literally peering back in time. However, you're probably intelligent enough to know that you are not actually looking back in time, but rather at a current light pattern that no longer precisely resembles the pattern of light from when you shot the photo 10 years ago. Similar to this, we can only infer the past from present-day light beams hitting observatories directed at far-off galaxies. If the light has not altered through time, a more accurate portrayal of the past would result from the light from distant galaxies changing as it travels, but this change would have to be in ways that humans can comprehend. The redshift that results from the universe's expansion is one significant alteration to light as it passes across intergalactic space. Fortunately, since the redshift is now well understood, it is possible to shift the light pattern back by the proper amount to provide an accurate picture of the distant galaxy at the time the light was emitted. From just a few galaxies that were previously known to exist, the James Webb Telescope, JWST, has now revealed hundreds of ancient galaxies that might be among the first inhabitants of the universe. According to a recent study, these very young galaxies displayed intricate structures and star formation clusters as early as 600 million years after the Big Bang. The study is a result of international cooperation known as the JWST Advanced Deep Extragalactic Survey, which collected data over the course